Hello everyone, my name is Ranjit. I welcome you on the Tuition Rocks channel. This is the online and offline platform for clearing all your doubts and the concepts. So today I'll be continuing with the extensions of the remainder theorem and factor theorem. In the previous video, I have already discussed the concepts regarding the remainder and the factor theorem. So if you're watching for the first time, I would highly recommend you to see the previous video so that your concepts are very clear. So today I'll be discussing about the problems related to the remainder and the factor theorem. So let's get started. So I have written one question here. Based on that, find the value of k if the x minus 2 is a factor of x cube plus 2x square minus kx plus 10. Hence, determine whether the x plus 5 is also a factor. So we already know what is called the remainder theorem, and we know already what is called the factor theorem. Right? So now, if you look at the question, he clearly tells find the value of k if the condition is given to you that x minus 2 is a factor of this polynomial. That means we have the polynomial. Let's write down the data. F of x is nothing but x cube plus 2x square minus kx plus 10. Okay, now we need to divide with x minus 2. So x minus 2. So the question says that x minus 2 is actually the factor of this, because then as per the remainder theorem, when we put equated x minus 2 equal to 0, then we get x is equal to 2. That means when you substitute the value of 2 in this polynomial, the remainder should come as 0. So the gist of this problem is, the statement of this problem, we can map it to that f of 2 should be equal to 0. Now how do we do that? Now let's try to understand that. So we'll substitute the value of 2 here. So it becomes a 2 cube plus 2 power 2 square minus k into 2 plus 10 should be equal to 0. This is what the whole meaning of this first statement. Now we'll solve it now. So it becomes a 8 plus 8 minus 2k plus 10 is equal to 0. 8 plus 8, 16. 16 plus 10, 26 is equal to 0. Now 2k is equal to 26. Now k is equal to 26 by 2, which is nothing but 13. So answer is, so for which value of the k? So we got the k value is 13. Now same thing we'll be doing with the where the next extension of this question is whether x plus 5 is also a factor of it or not. So we'll use the same thing. Now we'll equate the x plus 5 to 0. We'll get the value of x plus 5. X is equal to minus 5. Now we will test now, because we need to check whether, we don't know whether x plus 5 is a factor or not. Depends on the value of f of minus 5. What is the value of f of minus 5 will determine whether x plus 5 is actually the factor of this polynomial or not. So let's try to substitute this value. Now it becomes a minus 5 whole cube plus 2 power minus 5 whole square minus k minus 5 plus 10. Okay. Now what is 5 power cube? It becomes a minus 125. Pi square is 25, it becomes a 50. Now minus into minus plus 5k plus 10. We already know the value of k. K is 13. So let's try to substitute the k value is 13 only. So it becomes a 13. Okay? 13 to 5 is 65. It's being 65. Okay. Now let's try to find out this. Minus 125. 65 plus 15 becomes 115 now, and then this becomes a plus 10, right? So it becomes a minus 125 plus 125, which is equal to 0. So what we get here, f of minus 5 becomes equal to 0. So as per the factor theorem, we know that, if any of the, when we substitute the value, if it comes equal to 0, that means that polynomial will be a factor of the other polynomial, right? So this is the simple way in which the problem has to be solved. So let's recap what exactly we did in this question. Right? The question was asking that, find the value of k when this is the factor of this. So we know that when something is a factor of this polynomial, then f of this value, x value, should be equal to 0. So x is nothing but 2 here, then we equated this to 0, and when we equate this to 0, it comes as a linear equation for us, and which actually yielded at the k value. So we substitute the k value in the equation above, and then second question was asking whether the x plus 5 is actually a factor or not. So we'll use a similar method, but here we don't know whether it is coming 0 or not. So depending on the non-zero or the 0 value, we can determine whether x plus 5 is a factor or not. I hope this makes sense to you, because most of the questions will be related in this aspect only. There can be multiple scenarios, but the method or the way to solve this problem remains the same. So most important is you understand the concept and then apply the concept in the problems. I hope this makes some sense to you, and please share this video to all your friends who have the similar kinds of doubts, and you want to understand the concept in the case of the factor and the remainder and the factor theorem. And I'm sure, you have more responsibility to share with all your friends. Let's make this country a better place to learn. I believe in you guys. You are the best. Thank you so much.